Here's an exam question on normal distribution. If height of a family of plants were normally distributed with mean of 5 inches and standard deviation is 0.5 inches, what percentage of this family of plants would be between 4 inches and 5.5 inches? A couple of very important concepts here. First of all, let's talk about the means of a distribution and of course standard deviation. Here I have a graph over here and I would help to understand what we're talking about. This was taken from a Saxon book, and let me quote the source, Saxon textbook. So a normal distribution has a mean, that's where smack in the middle, and the spread of the data is called sigma. Okay, so between 1 sigma on each side, 68% of data would fall in. And if you expand it in between 3 sigma spread, 99% of the data will fall in. Now, a really good question I was asked once in the lecture is what does that mean? What all this math means? So on the side, I have a very, very simplified picture, and we can take a look at it together. Okay, so let me move this one out of the way. In a very simplistic way, here I draw, if you were to go, say, Grand Central Station, New York, and observe the height of the people there, and that's just very, very simplistic. This group over here has the same mean as this group, as in if you average, the height is over here. However, this group has very small sigma, as in spread of the data. This sigma here is very big because the height difference is a lot bigger. Okay, so in a very general sense, sigma means spread of the data, where mean, we'll call it M over here, or mu for most of the case actually, is the average. Okay, so given those data, let's solve this problem. Now that we understand what the problem is, let's go ahead and solve this problem. So let me draw a normal distribution, and with mean of 5 inches, and spread is 0.5, so let's write a 0.5 inch here, 0.5 inch here. And then one spread on this side is only 0.5 because we were asked 5.5 and 4. So on the left is 2 spreads away, and on the right is only 1 spread away. So in order to find the area underneath, basically that's what we're asked for. We basically need to find this chunk first and this chunk, and the area in between is subtraction of the two. So let me call this one A, call this one B. The area that we're interested, the answer is going to be B minus A. Okay, so to find A, looking for A, here's what we're going to do. A represents the area underneath the curve that's signified in the green part. Okay, so let's find A. We're going to use the Z ratio. This is a pretty standard procedure. You take the data you want, subtract from the mu, and divide it by sigma. Here we're looking for 4 inches. Mu is our average, it was 5 inches, and sigma is 0.5 inches. And if you plug in the number, Z of A is minus 2, I believe. And now here it's a pretty standard normal table. If it's minus 2, we're going to find it on this table. Minus 2 is, where my pen here? Minus 2 is this number over here, 0.028. Okay, so once we find this number, let's put the percentage over here for us, 0.0228, or basically 2%. So data points that would fall into this height on the green part over here, this is the ZA, is only 2% roughly. Okay, we're going to do the same thing for part B. ZB here in red. Now this chunk is the ZB here we're looking for. So ZB, using the same thing here, I'm just going to write it out quickly. reading on the table over here, simplify, and we got a 0.84. So 84.13% falls in data B. Of course, then here's our answer, subtracting the 84.13% from, actually the other way, 0.02. Here, let me put it in the percentage form so to keep our data the same. So this one is actually 2.28%. And here's our answer, which is 81.85%. So to fall into the height between 4 and 5.5, our answer is 81.85. Well, I hope this one helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video. Together, we can make a difference.